Hello everybody, and welcome to the second generation RYZEN Threadripper processor update. As we come close to our new product introduction, I want to give you all the information and details on this brand new processor lineup. And first of all, I want to tell you about our momentum with the existing RYZEN processors. What's happened so far with our, first of all, having the first 16-core 32-thread high-end desktop processor with the first generation Threadripper, the first 8-core 16-thread performance desktop processor, and the first 4-core 8-thread ultra-thin notebook processor has given us leading-edge performance in each of those market segments and generated incredible industry acclaim. 550 plus industry awards across the RYZEN family has helped us to generate some great adoption rates with brand new designs. We expect to have 60 new RYZEN processor-based systems from our global OEM partners expected by the end of year 2018. And that really has helped drive some incredible growth for the business, a 2 times mobile unit increase from Q1 to Q2 in 2018, just showing that accelerating demand and increase in preference for RYZEN processors. So with the Threadripper series, the second generation Threadrippers, we looked at our products and wanted to really understand who is our market, who are we thinking of when we design these processors. And we'd always wanted to have a broad range, a big lineup of products for the Threadripper customer. So we consider them in 2 different buckets: enthusiasts and gamers, and creators and innovators. And it's those creators and innovators that we're really thinking of when we develop these 32 and 24 core solutions, the digital Einsteins, the people who are using PCs every day for their work. They are fully focused on time to completion and the absolute best performance. And that's why RYZEN Threadripper was designed for those who desire the highest performance possible. So our new WX series CPUs are intended for those creators and innovators. It's the ultimate processor for those high-end, intensive, multi-core workloads. And we introduced the RYZEN Threadripper 2990 WX processor first on August 13th, 32 cores, 64 threads, 3 gigahertz base frequency, and a 4.2 gigahertz boost frequency, giving that beautiful balance of performance for massively multi-threaded applications and lightly threaded applications that are bursty and transient and need fast processing inside of the same system. Later in October, we'll follow up with the Threadripper 2970 WX. That's a 24-core, 48-thread processor, again 3 gigahertz base, 4.2 gigahertz boost, and priced at just $1,299 compared to the $1,799 for the 2990 WX. So with our WX series, we're using the 12 nanometer Zen Plus architecture you saw from our second gen RYZEN processors, and that brings all those cool features into this product segment and these class of products. And the best part is they're all existing platform, the socket TR4 compatible, existing motherboards work, existing coolers work. It's a very simple and easy update for our ecosystem. Now for our enthusiasts and gamers, the people who are looking to buy a future-proof system, they want cores and threads because they do all kinds of interesting things from productivity to professional workloads to occasional gaming to tweaking and tuning. They want expandability with the class-leading 64 lanes of PCIe that Threadripper platforms offer. That's what the X series is for. So we'll have on August the 31st the 16-core, 32-thread RYZEN Threadripper 2950X, 4.4 gigahertz boost frequency, 3.5 gigahertz base. Very high frequencies for this class product. We're very excited to see how this is going to be introduced to the market and adopted by our enthusiasts and gamers and streamers. Following that, we'll have the RYZEN Threadripper 2920X, which is a 12-core, 24-thread product. Again, 3.5 gigahertz base and 4.3 gigahertz boost. That's coming in October. Some great pricing here. Year on year, we're coming down in price for our 12 and 16-core processors, delivering more value in the platform, continuing to be very, very linear in our cores per dollar. So when you consider RYZEN 7 to RYZEN Threadripper to RYZEN Threadripper WX, you're getting very, very clear delineation of spending more money to get massive boosts in multi-thread performance. Each time you buy up, you're getting a lot more cores, a lot more multi-thread performance. So let's go deep into some of these new products and find out what's inside, how we built them, why we built them. So there are three objectives: to go bigger, better, and easier. So we want to do an improved experience over the first-gen Threadrippers, but while still offering an unprecedented amount of compute for the users that demand it. And that's why our second-gen lineup includes both the 2-die 12 and 16-core products and the 4-die 24 and 32-core products. And above all, we had to maintain compatibility. We needed to leverage the brand new ecosystem we just created 1 year ago and drive it to new heights, increase the adoption, make it simple and easy for enthusiasts, for creators, for all those professional users out there to get part of the Threadripper family. So with the X series, we were really thinking about the enthusiasts and gamers, the guys who are not just gaming, but gaming and streaming, or they're gaming at high resolution. They have a use for cores and threads, but they also have a need for gaming and fun. So we did that with our Zen Plus core, which is our brand new 12 nanometer die design, 2 of those inside the product, but massive amounts of multi-threading. And if we compare that to the price point competition, which is around about $1,000, Core i9 7900X, we can see that we're very close on the single thread performance, within 6%, which is really an unnoticeable difference in most lightly threaded applications. You're not going to be able to tell about that difference right there, but you will notice immediately and obviously the 40% benefit of RYZEN Threadripper in multi-threaded applications such as productivity, prosumer applications for creators, rendering, lighting, modeling, video encoding, video production. They're all going to be strongly benefiting in comparison to the competition. So you're not really giving anything up when you go to a 2950X. When you look across the heavy workloads, from rendering to encryption to compression and decompression, or blockchain compute and media encoding, you can see that our advantage ranges from 18 to 50 to 60%, even over 100% in some of those brand new workloads like blockchain compute. And that's due to the strength of both our product design and our platform, as well as our number of cores and threads at the price point. The beautiful scaling of simultaneous multi-threading that we offer with Zen Plus architecture really lends itself nicely to rendering and encryption algorithms, compression and decompression. We have very high performance there. And that's something you use all day, every day, working with archives, working with secure files, working with rendering and other types of applications. But we're not just talking about productivity, we're talking about gaming. And here you can see where we are competitive. We have a very good gaming experience with the Threadripper 2950X. Tying the Core i9 in many titles, very close position. The worst was 10% back in one title, but that 10% difference isn't so big that you can notice it. It's a small difference, talking 99 to 90 FPS style difference in performance. It's an imperceptible difference, around about a millisecond and a half in terms of frame times. And so when you're considering overall the whole platform, you're getting gaming that feels, that looks, that experiences identical to the Core i9, but you get all those previous performance advantages, up to 40% more rendering performance, up to 60% more encryption performance. Those are tangible, meaningful benefits, especially for this class of buyer. People who are buying 16-core processors are not focused solely on gaming. Those buyers are looking at our Ryzen 7 and Ryzen 5 lineup. They're looking at those because of the price point, because of the great gaming performance, and because of the platform cost overall. If you're looking at a Threadripper system, you're really concerned about more than just gaming performance. You want to know about platform scalability, longevity, expandability, and everything else that goes along with a premium high-end desktop system. And that's what we offer with Threadripper, is all of those things. So to enable this design, we use 2 of our die, taken from the top 5% of RYZEN die, and we connect them together using the Infinity Fabric, which is our secret sauce, our specialness that lets us develop these kind of products. It's an incredibly efficient connection. Even though we're at 50 gigabytes per second bandwidth between the 2 dies, we measure and control power at a picojoule per bit level. So very, very tiny amounts of energy per bit transferred gives us a massive advantage in building these kinds of products. You can see from our diagram here that each die has 2 memory channels attached to it. So we have the ability to support quad channel memory, And if your workload is running on die 0 and you're using the memory attached to die 0, you've got just 64 nanoseconds of memory latency at access in those different memory banks. If your memory data is in the opposite die, then you're looking around about 105 nanoseconds for the far memory zone. Still very, very fast latency through the different parts of the chip. Very simple and easy to connect with that 50 gigabytes per second die-to-die bandwidth. All the devices PCIe Gen 3, straight from the processor, each available to both chips from the socket. So that's how our X series were better than everything. We included a whole bunch of new technologies when we developed second gen Ryzen, and those come into the second gen Ryzen Threadripper X series as well. Looking at WX series, we've started thinking more about creators and innovators, and they still have a need for bursty single thread performance, but they need the ability to scale up massively in terms of cores and threads. And asking us why we built this is pretty simple. We'd always planned on wanting to have a 24 and 32 core roadmap inside of RYZEN Threadripper, but we needed to wait for the 12 nanometer die, the new precision boost, the improvements available from the faster, lower power transistor that enabled second gen Ryzen and second gen Ryzen Threadripper to be available. And looking at the user sentiments, there are a lot of people who felt the same way. We need this. They don't need it, but they want it. And that's what we are happy to supply with our RYZEN Threadripper WX series. So in terms of competitive positioning, our product 2990 WX, $1,799 US recommended retail price, competes against the top of stack from the competition, Core i9 7980XE, which runs around $2,000. In terms of single thread performance, this is the closest you've seen on our product stack today. It's only 4% difference. Again, not something you're going to notice day to day, but 50% multi-threaded advantage delivered by that 32-core, 64-thread processor. Massive performance. Makes it the world's fastest desktop processor in the HEDT segment, and that's going to be a real and meaningful difference for many applications. If you look at some of those heavy workloads like ray tracing, rendering, compression, then you're going to see 13 to 30 to 40%, even nearly 50% improvements in real-world application performance. So the raw power of the processor delivers significant performance advantages at a price advantage platform. So even though this is a price segment where the total solution cost pales compared to the application licensing to some of these workloads, application fees, we've got incredible performance and still delivering incredible value. It's a very good story for AMD and will help to drive the Threadripper WX series to much success. So we have some differences making this product. Now we move from 2 dies to 4 dies. So we've got 4 8-core dies inside of the 2990 WX processor. And each die is connected to every other die with that Infinity Fabric connection. So you get 25 gigabytes per second die-to-die bandwidth. So every die can talk to every other die at the same time. We've got beautiful low power, still worrying about picojoules per bit on those transfers to ensure low power and high performance. The latencies are unchanged for our 2 die that have direct memory attached, 64 nanoseconds of near memory. For our die that access memory through the other 2, then they're looking at 105 nanoseconds of memory access. So now as we start to develop our processors and our technologies, you can see that we can get very fast access for lightly threaded workloads, and then for the bandwidth that's needed for the heavily threaded workloads, that's delivered through the Infinity Fabric to feed those cores and threads. So the benefits of this topology is it means that all the lightly threaded cores and threads get direct access to memory, so that burstiness that's required means we get a nice, fast, high bandwidth but low latency approach. When you move to the 32-core type of workload, you're much more bandwidth sensitive than latency sensitive. So having those dies communicating with each other to access the memory doesn't really impact the performance. It just lets us add more cores and more threads into the same existing socket. It's fully compatible with AMD X399 motherboards that were launched last year, just a BIOS update needed to get the compatibility for booting. And the best part is all of these motherboards already have USB updating mechanisms. You don't need a first-gen CPU to update these motherboards. Many of them, you don't even need the processor in the socket. Just put the BIOS onto a specially named file on a USB stick, plug it into power, press the button, and it automatically updates. Very simple, very easy enablement without breaking any of our infrastructure. No dark lanes, no dark memory channels, just beautiful high-performance scaling. And it gives us a benefit of up to 64% faster than our 16-core product. The right tool for the right job. How do you understand which processor for your segment? Who are we trying to sell to? Who should be interested in buying it? Are we trying to encourage Fortnite players to buy Threadripper WX $1,799 processors? No, it's not what we're looking to do. We're very focused on WX, meaning workstation. It's very closely aligned to our Radeon Pro graphics cards that use that same WX nomenclature to understand who our market segment is. So serious 3D ray tracing and rendering, looking at broadcast quality rendering output for the character modeling, for video editing, for video effects, massive virtualization, 3D and VR animation and simulations, financial workloads. These are all the kinds of workloads we expect to see on WX series. X series is going to balance. It's going to straddle both sides, from 3D rendering and video encoding, maybe not broadcast quality, but for Twitch streaming or other online service streaming. Software developers who want to compile, maybe game sometimes to test their code, all in the same system. All of that's inside of the Threadripper X category. But if you're looking at PC gaming, basic productivity and photo editing for simply gaming and streaming online as quickly and easy as possible, that's RYZEN. So if your primary focus, your primary purchase indicator is gaming, you should be looking at our RYZEN lineup. Come back and look at our Threadripper X series, maybe for the longevity of the platform and scalability offered by all those PCIe lanes and that memory capacity and the high performance cores we offer. But really, we're not talking to gamers for WX, and we're not talking to professional creators for RYZEN. So bigger than anything is a bold statement for our WX series CPUs, and it's true. We offer them more cores and threads than anything else in the market, delivering more performance up to 50% more in certain applications. And it's all based on and created out of that Zen Plus architecture. Generationally, from first-gen Threadripper to second-gen Threadripper, we improved all of the latencies, memory latency, cache latency on L1, L2, and L3, up to 15% better on that L3 cache latency, helping the data flow, improving the throughput of the cores, raising that performance. And that was all made possible by the 12-nanometer process from our partners. We got a beautiful reduction in transistor voltage, so 80 to 120 millivolt core voltage reduction at any clock frequency. That helps us not only put more cores and threads into the products, it helps us increase the clock speeds too. So we got a faster transistor, it uses less power, and that's why we're able to suddenly go from 2 to 4 dies inside the Threadripper platform. We also updated Precision Boost 2 and XFR 2. Both of those affect the boost frequencies, the clock speed seen in day-to-day use, and that's really the heart of how we're able to make this 32-core product work and this 16-core product work. What we now get is, instead of a kind of a performance or clock frequency cliff for 2 cores and threads for applications that are lightly threaded, and then a base frequency, is a much more gradual, graceful curve. So it gives us substantial clock speed increases for real multi-threaded workloads. Everywhere between 1 thread and 32 threads is benefited by the increased new use of the algorithm Precision Boost 2. So we get this beautiful boost algorithm that you can see described here, and it's governed by the core temperature, the amount of current thrown through the VRMs, and the package power limit, the SoC power that's being dissipated by the cooling solution. We still maintain 25 megahertz granularity for the clock speed selection, and we can react to the temperature changes, the current changes, the power changes, the millisecond response time. Very fast, very responsive, very granular, and it applies to all the cores and threads in the system. And then when you look at the 32 core, you can see that same beautiful, graceful curve applying across all cores and threads. And here you can see it's possible for all cores and threads to run well above the base frequency. Here we're using the application OCCT, a thermal power test application. Very simple and easy to modulate the number of threads used and loading up in the system. And we can see that as the number of threads increases, the clock speed gradually rolls off of that boost speed down towards the base speed. And here we're running all 32 core, 64 threads at 3.4 gigahertz, because we're still inside of the core temperature, the current delivery, and the SoC power limits, well above that 3 gigahertz base frequency. So XFR2 is now on all CPU cores. Previously, it was a single core statement. If there was extra thermal headroom, then the processor would boost above its max boost frequency and go a little bit faster. Now, because of Precision Boost 2 applying to all cores and threads, it's all about that extra thermal headroom you just saw on that Precision Boost curve. So if you take the RYZEN Threadripper 2990WX processor, which is a 250 watt TDP processor, all the WX processors are 250 watt TDP, and you put that into a hot environment, 32C ambient, I put an underspec cooler on there, 180 watts, then what you will find is when you switch to one of our partner coolers that's rated for 250 watt, like the Cooler Master Threadripper, you can see an 11% boost in performance. So that's that XFR letting you go faster because of extra frequency headroom, because of the temperature. Move the ambient temperature into something more like everybody's office, an everyday room, 20C ambient, then you're going to see a few more percentage points increase. Upgrade your cooling from air cooling to a liquid cooler, and again, you'll see more performance. Overall, up to 16% more performance delivered by going to a cooler room and a better cooling solution. You didn't need to change anything about your configuration. You didn't have to buy a different processor. You just had to adjust and modulate some simple components that you're already worried about today. A cool room and a nice high-end cooler. We're going to give you the most performance out of the box. Let's talk a little bit about the Cooler Master Threadripper. Designed by Cooler Master in collaboration with AMD. It's called the Threadripper, and it features the AMD RYZEN Threadripper logo on the top. It's manufactured and distributed by Cooler Master, has a 250 watt TDP. The center mounted fan is very quiet, up to 38 dBA under max frequency, max load at 2500 RPM. But it's got this beautiful blaze of luminescent glory across the top of these per LED RGB stripes that give you multi-zone adjustability. It's got a copper base, copper heat bites, an anodized aluminium fin stack, and it has sculpting on the bottom of the cooler to enable those 44mm tall DIMMs to fit underneath the cooler next to the socket and be compatible with different motherboards. Some motherboards have their top PCIe slot very close to the socket, and like some of the other third-party solutions in market, this may have an overlap or overhang on that first slot, but those designs that use AMD's reference design for their motherboard will have no clearance issues. That first slot will be easily available and able to select in. One of the benefits of the RYZEN Threadripper platform is 64 PCIe lanes. So if you've got a top slot that's covered by the cooler, there are plenty of other lanes to use, and smaller devices than graphics cards will be able to fit into that slot and not have any issues. A PCIe NVMe riser, a NIC card, other different devices along those lines. So this is going back to what I said about all those PCIe lanes. You can see that our platform is very advanced. We believe it's the most advanced desktop platform in the world. First and second gen CPU support enabled by BIOS update, and there's no dark I/O lines. It doesn't matter whether you buy the bottom of the range first gen RYZEN Threadripper 1900X or the top of the range second generation RYZEN Threadripper 2990WX. All processors give you all the memory channels, all the PCIe lanes, all of the features, and all of the performance that's available in each processor. They're all unlocked for overclocking or performance tuning. They all allow you to use NVMe RAID or SenseMI performance features such as Precision Boost and XFR. So we've got some new motherboards coming and joining the ecosystem. Gigabyte and MSI launching new boards to go along with their existing lineup. So all the existing boards compatible, as I said, with the new BIOS update. Gigabyte and MSI compatible out of the box with their, even though these pictures are very colorful, these are very workstation-focused designs. You have the Gigabyte X399 Gaming Extreme and the MSI X399 MEG Creation. We're equipped with 10 gigabit LAN, additional 1 gigabit LAN, 802.11ac 1.5 and 1.2 gigabit per second Wi-Fi, and Bluetooth. These are very advanced motherboards with high-end connectivity, high-end designs, and really optimized for second-gen Ryzen Threadrippers. But all the existing boards work well with our existing processors and our new processors as well. It's a very exciting and interesting ecosystem update for us. More ecosystem updates around coolers. We have new liquid cooling solutions, 6 new water blocks coming to market, full coverage, so you can make sure that whole processor is covered up and pasted when we add those coolers to them. And then we've got 4 new thermal designs for air cooling, including Cooler Master, Arctic, and Thermalright. Makes for a broad range of ecosystem updates. We started off with 16, 17 coolers validated by AMD for first-gen Threadripper. Those are continuing to be validated for second-gen Threadripper, including the WX series. So we're still including inside the processor box the adapter bracket for Acetec-based coolers, so you can continue to use those with second-gen Ryzen Threadripper's WX and X series processors. We're also enabling StoreMI on all X399 motherboards. As of August 13th, this will be available for download, and it's the same beautiful storage acceleration tiering software that you saw on X470 and B450 motherboards from AMD, now coming to all AMD X399 customers. And because it's StoreMI, you didn't know you needed to want to have this before you built your system. You can add it at any time. You can create a bootable volume or a non-bootable volume to accelerate your storage. So even if you built your Threadripper system a year ago, you've got a high-performance NVMe for your applications and OS, you've got a large rotational drive for your existing data sets and other applications and games. You can now make that large data drive go faster with perhaps one of the old SSDs you have laying around at home or a new one on sale from recent sales. Add it into the system, create the fuse drive, and enable StoreMI, reboot, and you've now got that secondary storage accelerated with the speed of SSDs. It's incredibly fast. Applications that are stored on StoreMI will load up to 90% faster than a regular rotational hard drive by itself. And it does this by moving the blocks, the most used data, from the slow storage to the fast storage. So it's not caching, it's moving the data and making it go faster. We also combine that with up to 2 gigabytes of DRAM cache for even the fastest load times. So if you happen to be sitting there inside a game and you're loading in those different levels, it's going to load from memory cache instead of from hard drive every time, helping you keep gaming and move faster every time you want to play. We have a new version of Ryzen Master for Threadripper CPUs. Tons of new information and features in here. At that top line, you can see there's some new parameters you can see, PPT, TDC, EDC, and PTC, and they're all part of the definition that is updates that gives us Precision Boost Overdrive in Threadripper, and I'll talk a little bit more about that in just a second. If you're interested in tweaking and tuning Ryzen Threadripper, you may want to know which are the cores with the most potential for high-frequency overclocks, and we can identify those per die with the gold star. And then inside of each CCX, we can identify the fastest core potential and the second fastest core potential. So gold star is the fastest core in the die, most potential. Silver star is the second. Then we have the white circles, and that's inside the CCX, the second most potential for overclock high frequencies. We also add the new control mode, Precision Boost Overdrive. You see that in the center of here. And you can toggle that off simply and easily to increase the performance of the processor. Basically relaxing the limits of platform power target, thermal dissipation current, and electrical design current, so that you can get the maximum out of the motherboard without having to do lots of manual tuning and tweaking. And that's really important because what you're looking at when you're tweaking and tuning is an all-core overclock in manual overclock mode. And that takes away the ability for Precision Boost to operate and give you the full maximum gigahertz. It's very hard to cool a processor with 32 cores and 64 threads enough so that all cores and threads can run concurrently at the peak boost frequencies. But Precision Boost Overdrive gives you the most opportunity to increase performance from lightly threaded and multi-threaded applications, so you still get that single thread boostiness and the massive multi-thread performance. So looking at the memory layout, you may be aware of NUMA, non-uniform memory access. So our processor operates in NUMA mode or Unified Memory Architecture mode for our X series. All of our WX processors are in non-unified memory architecture mode, NUMA, and can't be toggled. But the 2950X, 2920X can be toggled to unified memory architecture mode. The benefits of this local mode is that the apps that need the fast DRAM access, the low latency application, they get that data straight from the die connected to the RAM. It's very, very simple and fast. If you've got a unified memory architecture for those more multi-threaded applications, you get more performance across the entire chip at the expense of some of the burstiness. So that's really why there's those two different modes, and you can see that mode, distributed mode and local mode, represented inside of RYZEN Master. It's a boot time operation, so you toggle it, change it, reboot. You can't do it on the fly. It's only configurable at boot time. What that does is impacting your performance is changing the amount of memory bandwidth that you can get. So you can look at that red line showing the unified memory architecture. So as you go down in threads, then you can see that the memory bandwidth is impacted. So a 16 thread on die 0 has 40 gigabytes per second of memory bandwidth. But when you go down to two dies using two different dies using the same amount of threads, 16, then you get to 60 gigabytes per second. So the unified memory architecture flattens some of that performance delta between using one die and two die. More performance for when you have all of those cores and threads on one die using that single memory channel, single dual channel memory controller on the first die. But as you go to NUMA and you're using local, then when you're using multiple dies, the memory bandwidth goes up. More memory bandwidth because more cores and threads are working on the same problem together across two dies is a better thing. And that's why local mode, the NUMA, is our default. So this describes to you some of the different settings in RYZEN Master. You have a legacy compatibility mode. We've found some games that just won't run on high core count processors. They would prefer to have less cores and threads. And while we're working with those developers to resolve those issues, in the meantime we have a compatibility mode so that these older games can be compatible without having to wait for the patches. So you can see the on-off status, obviously off by default. It reduces the thread count by half, but still leaves the die active for the PCIe and memory controllers to be used. So you still get all your memory capacity, you still get all your PCIe lanes, just only half of the cores and threads are able for processing. Memory access mode, local versus distributed. Distributed maximizes the memory bandwidth, and the local mode just reduces your latency. As noted before, the RYZEN Threadripper 2990WX and 2970WX do not use this toggle. The default is always to be in NUMA, the local mode. However, distributed mode is the default for 2950X, which is your unified memory architecture mode. So we also have a game mode, as hinted towards that legacy compatibility mode. That game mode preset gives you 8 cores, excuse me, 8 cores on the 2950X. So that lets you use all of one die with the lowest memory latency and the highest precision boost clock speeds you've seen on a RYZEN processor for the most amount of performance. So very similar to a 2700X processor, the RYZEN 7 2700X, a little bit higher boost frequency, a little bit lower memory latency, and the same configuration of 2 CCXs on one die for performance. So what that does is give you small amounts of performance benefits for lightly threaded games, up to 8% in certain titles, but most highly threaded or bandwidth sensitive games should be run in the default mode. It's just an option for you to try and test and compare versus the different modes. So out of box, when you're trying to overclock the first gen Threadripper, you can go with the stock base and boost frequencies and get a pretty good level of performance, class leading at the time of introduction for the world's fastest desktop processor when launched. And when you go to the overclock mode, you lose precision boost. And depending on whether you are overclocking for single thread or multi-thread performance, your performance level went up or down, because it was controlled by the manual use of all cores and threads. But most users want to retain that single thread performance and increase the multi-thread performance. And that's why we've introduced Precision Boost Overdrive. What Precision Boost Overdrive does is pull some of the levers that affect Precision Boost 2 to increase performance. So we can increase the power limits to the limits of the motherboard and still have the smart Precision Boost voltage frequency curve and give you the full one single thread performance boost. And what that looks like in operation is, when you toggle it on, you can now adjust the package power target, which is how much power the SoC can dissipate, the thermal design current, which is the motherboard's capability to radiate heat away from the VRM and power delivery section, and the electrical design current, the peak current deliverable from the motherboard to the socket. And those three things are in place to avoid burned pins, to avoid overheat conditions, to avoid popped VRMs. So PBO will let you expand from the AMD definition of those targets to the motherboard limits. So you can now push up safely, but still outside of warranty, and understand how you can get more performance from the processor. It's easily toggled from within AMD RYZEN Master. It doesn't need a reboot, so you can turn it on and off per application, however you want to use it. And what it does is, an example would be a good one here would be CINEBENCH. You can get up to 13% more multi-thread performance at the push of a button. So for multi-thread applications, a ton of more performance sitting inside the box just with toggling on and off with Precision Boost Overdrive. Obviously, improved cooling, a better power supply, improved chassis thermals are going to be required to use PBO to maximum effect. And it is an out-of-warranty condition. When you open RYZEN Master, it will advise you that toggling these different options could result in a voided warranty. So you are not using this as an AMD overclock mode, it's end-user overclock mode. So the X399 platform gives you easy upgrades with great scalability, now letting you scale all the way up to 32 cores and 64 threads with a massive amount of performance. And if you look at the way that our performance scales, because we didn't double TDPs, you don't get true doubling of performance. For example, the 2700X is a 105 watt TDP processor. The 2950X is a 180 watt TDP processor. We don't double in multi-thread performance when we go to that level. And then from the 2950X to the 2990WX, we're going from 180 watt TDP to 250 watt TDP. And this is really all about making sure we've got the right performance for the price segment and for the upgrade that we're looking to deliver. But competitively, we've got a fantastic story. Here you can see, versus the competition at the same price point, 40% more performance from the 2950X than the i9 7900X. And in fact, here you're looking at 16 AMD cores offering more multi-thread performance than 18 of our competition cores at less than half the cost. Still going further up, dominant multi-thread performance, the world's fastest desktop processor for HEDT is the Threadripper 2990WX. Still at a price advantage and a massive performance advantage. So better at everything, I think we checked that box by using that 12 nanometer architecture, Zen Plus cores, Precision Boost 2, and enabling Precision Boost Overdrive and adding SenseMI technology to the platform. Massive updates in every area of the platform, from storage to performance to architecture to key technologies. Bigger than anything, there's nothing else out there in the single socket desktop space that offers 64 threads of multi-threaded performance and this performance level. And this was all delivered with easy BIOS upgrades, no new coolers, but we have them anyway, no new motherboards, but we have them anyway, and seamless compatibility. Very simple and easy, an excellent overall story. And that's our second gen RYZEN Threadripper processor lineup. Just to remind you on the introduction, August 13th first on the 2990WX, followed by the 2950X on August 31st, and more details to come on the specific date for the 24-core and 12-core 2970WX and 2920WX in October. Thank you very much. Please contact your local representative for more questions. We're done.